Good morning, everybody. Welcome to this session. Good morning for people in the room, people online, whatever time zone you are. So I'm Kalyan Kaki. I'm a group product manager, Azure, and I'm here to introduce you to our next session for Oracle Database at Azure. As a quick reminder, last fall, fierce competitors, Oracle and Microsoft, came together for our joint partners to unveil something really magical. We have ever since started offering Oracle Exadata Cloud Service in Azure. We started with East US region. We went live in 4 regions. And today, here we are, starting the next wave of the journey. Let me introduce Kambiz, our Vice President of Oracle Database at Azure from Oracle, and Marty, Program Director of Autonomous Database, to talk more about the brand new offering, which is Autonomous Database working at Azure, and also give you a ton of demos. Kambiz, take it away.
Thank you, Kalyan. I appreciate it. It's a pleasure to be here. Thank you for those folks who are here in person and those who are online joining us. So the flow of the presentation, I'm going to go through 10, 15 minutes at most, and I'm going to pass on to Marty to actually show you really how this thing works and how simple and easy it is, which is the kind of the critical part here. So did the introductions. Modern application development has become really, really modernizing, going through transformations. It's becoming decentralized. It's becoming very complicated. When you look at it from ways to deploy applications as an application developer, you're dealing with multi-modes of operations that you have to deal with. You're dealing with containers, you're dealing with Kubernetes, you're dealing with concepts of clouds and otherwise. When you think about the architecture in these apps, there are a variety of things you have to constantly think through as how you're utilizing microservices, how you're utilizing data mesh, how you're utilizing low code, no code, and API-driven application development. When you think about the underlying, go further down from a data type and data modeling perspective, you're dealing with and have to deal with a variety of data types, include JSON documents, including transactional, blockchain, including special processing, including graphs. And so you have to, as an application developer, you have to constantly figure out kind of how do I connect these things to one another? What do I need for what? And how do I optimize this for the use and what query and how, right? And so as you kind of look through this a little further, is that from the top, when you're simplifying the application development from the bottom, that creates a ton of complexity on how the database architecture needs to operate, right? How the data estates, data assets, how the databases, how the infrastructure is supposed to operate to optimize for workloads, for the queries, for things that you're hoping to accomplish at the top, which is performance, availability, scale, and all the good stuff. So what these usually and typically force the application developers to have to deal with forced, heterogeneous, distributed data modeling, data types, deployment architectures to have to work with one another. How do the ETL between these things could work? How do I have an interoperable framework that I can have them be not doing a ton of table joins, but have these things being connected to one another in a very seamless way and deliver data insights out of them for my customers or for myself or the application. Oracle has innovated and pioneered this concept of converged database, which basically how do we go away from the single-purpose databases, single-purpose data stores, and how do we simplify from the architecture, from the data type, data modeling perspective, the view and unification access to all these different types of data models, data types, and so on and so forth. So here we are announcing Autonomous Database Service. Autonomous Database Service is a database as a service on the enterprise #1 database platform in the world. It simplifies every aspect of the database as you can think of. Self-driving, self-securing, self-repairing. So you have to really just focus on your application development and what is that you want to do for the customers. So we are in that business of making it, you don't have to worry about anything around the database and the management, the movement of the data per se. So all that kind of mundane, generic database management tasks, not have to worry about it. And you can really focus on performance, security, data modeling, and what works as a DevOps, or if you're using, for instance, JSON, offer you kind of API compatibility with MongoDB, or even better functionality at times on our JSON support than MongoDB for you. When you think about what we just talked a minute ago about new generation of data technologies, which is where we are looking at it, this is an opportunity to create value for developers, right? So if you're using or if you're utilizing and building use cases around optimizing delivery of packages that you need to use spatial data, you need to use graph data, you need to use all kinds of different sources of data. If you are trying to come up with use cases around security threat detection in near real time or real time, around entities, around graphs, utilizations of those in and across transaction data at the same time, or JSON, whatever that might be. Or if you're looking at the telemetry of your data and how it's being utilized, or the infrastructure underneath, how can you simplify the utilizations of all of these next to one another and driving value out of them right simply next to one another. So back to the Converge database, it's the best in breed support for every data model and workload you can think of from one unified access. So you're familiar with SQL, the same SQL that you're familiar with transactional guarantees, everything you have at the SQL that you can work around. Same SQL, same REST API, and transactions operate across all the data types. So you're able to utilize relational data, JSON, XML documents, graph, text, spatial, blockchain, or machine learning. And we're going to get to that, Spark, or whatever else that you're interested in using, all in and under one roof in a very unified manner. So just to clarify, this is not about monolith, right? This is having that you still have these things to be in the best optimal fashion they need to be, but the unification of the access to them is democratized. Unification of access to them is offered to you, and so that you can really focus on the right data architecture that is good for the business. So in this case, for instance, a little bit more specificity here. If you're using Spark for machine learning, or if you're using Kafka for enabling the microservices, if you're having IoT applications, you're developing a blockchain or relational, non-relational documents, the point is that providing simple access and simplicity of managing, and not actually having to manage all of that. So moving to the next segment about what is Oracle Database at Azure and why. 98% of the companies, they are in multiple clouds. We recognize that, right? We are competitors as Oracle and Microsoft, but at the same time, we leaned in. There are customer use cases. There are times that customers actually want us. They have both solutions, and they say, instead of you being in separate places, we be having to constantly fight, how can we make this a reality for us across applications or use workloads that have to operate across multiple clouds instead of being separate? We dove deeper into that. When you look at it, 10 out of 10, banking, automotive, healthcare, communications, 9 out of 10, there are Oracle customers as well, right? And then when you look at the cloud migrations from on-prem to the cloud, there's still 70% of upside there that still customers are waiting for solutions that don't have to make a choice. That, hey, I have to be on Azure or I have to be on Oracle. Can you come up with a way for me to simplify that I can continue to have business continuity, continue to operate on where I want to be, and without having to have issues across how these things need to come together. And hence, our leaders came together. Larry and Satya sat down together and started working out some of these problems. That from a database architecture standpoint, we have the best built technology to make it simple for customers with a converged database model. From the application development standpoint, Azure has the best in breed, best in class Azure services on top, right? And so how can we make this to be seamless and make it a reality, the holy grail for the customers? As a result of that, customers on the database architecture and database standpoint, they're able to get the highest availability, full automation, fastest performance, and agility that enterprise customers, over 80% of them today, are getting. But this is available to you as an application developer as well. And on the Azure, Microsoft Azure side, you have access natively to app services. You want to use identity, you want to use security, you want to use Entra ID, you want to use Microsoft Fabric or other services from a DevOps perspective, as an example, that you want to have them operate on your Oracle data estates in ways that natively you couldn't do before, right? So when leaders came together, it was sort of how do we make it a reality of the best of the both worlds for the customers. Autonomous database in one, we have different services that we offer on the Oracle database at Azure. One is Exadata Database Service, but Autonomous Service is one that allows you to take benefit of a fully managed, automated capability that you do not have to worry about at all, about provisioning, patching, upgrades, downtime, planned, unplanned, whatever that might be. We have a ton of technology behind the scenes that can give you zero downtime migration, can give you zero downtime upon going to minor, major version upgrades, depending on your workloads that you're able to utilize. And you still have the built-in low-code Apex, ELT, AI, ML, graph, and spatial analytics support at the same time. Just to simplify and close it out, again, the holy grail when it started mid last year was that how do we make access to different data types, different data models, and how do we make the application development on top simplified with Azure services? And this has come to reality today. We have kind of a bunch of regions worldwide and across different geos that are available for the customers today. And more will be coming up later this year and throughout next year. It's super easy. The operations is pretty simple. You basically go to Azure Marketplace. As of now, it's a private offer framework, but you go purchase in Azure Marketplace. It's very similar to how we do in OCI, but if you happen to go through where you're familiar with, which is Azure Marketplace in this case, you can deploy, manage, monitor directly through Azure Portal and APIs. So very, very simple, as you're familiar with as an Azure developer, for instance, with what you're doing. So no changes there. You have access from cluster VM cluster management or telemetry around the data. You have access to all the instrumentation that enterprise customers have access to. And you can build additional Azure services on top of that. And you can combine a growing number of Azure services on top of your Oracle data assets. So without further ado, I'm going to pass it on to Marty, who's actually going to show you in real life how simple that is to set up a data and get up operating it like in a few minutes, as well as all the good stuff about what we're here to announce. Thank you, Marty.
Awesome. Thanks, Kambiz. Hey, everybody. So this is going to be fun. Our scenario, I'm going to try to describe what Kambiz just went through demonstrations and how to kind of bring everything together. And we're going to do that through a use case called Oracle Movie Stream, right? So it's a fictitious online movie streaming company. Their goal, they want to delight their customers, okay? So the question is, like, how can they innovate? What kind of new services? They're always thinking, what kind of new services can I easily bring to my customers? So they're looking at things like, hey, we know what the movies that people watch, we know about their families. Let's create a new service called Create a Bedtime Story. So you can kind of snuggle up with your kids at night based on the movies that they watched. Let's create a story for them and we'll read them stories. I've got some really good memories of doing that with my girls. Encourage communities, right? With watch party events. Let's bring people together, people who watch the same movies, they have extended friendships. We're going to bring them together in watch parties. So they're just constantly trying to deliver new services to improve their business, right? So awesome. How? How do they do this? Well, Kambiz just talked a lot, all right, about how they simplified their architecture. They're using Oracle Database at Azure, and that's great, right? So they're able to use that one store, that one database for their JSON documents, for doing graph analytics on top of not just their JSON documents, but also on top of their relational data, and actually just bringing all of their data together, right? So they dramatically simplified their architecture, and across the application development, they're injecting intelligence all along the way, right? Applying generative AI to do things like create a bedtime story or to do promotional emails based on private data that only MovieStream has about their customers, but applying the power of AI to their data. And importantly, I mean, there's so many great Azure services, right? So we are helping you build apps faster by integrating with these great Azure services, right? So I want to share data with the Lake. Really simple through APIs to import and export data with Lake, or use things like pipelines and use Azure Data Factory, right? To make integration as part of your existing workflows, or with DevOps and code management, sharing code and whatnot, or sharing APIs. So they're using a combination of the best of Oracle and the best of Azure to do this. Okay, so let's get straight to the demo. Let's just show it, right? Stop talking, let's show. So what we're going to do is we're going to start by going into the Azure portal, deploying Autonomous Database, and then we'll explore some of the tools that you have available to you that are just built in. So at the end of the day, in just a few minutes, you're going to have this mission-critical database that's ready to go. So this is the first of a 5-part segment. so it'll be fun. So we're going to start in the Azure portal, right? And you have this new option, Oracle Database at Azure. And what I'm going to do is I'm going to spin up a new database. And I'm going to put, this all should look very familiar. I'm going to put it in the MovieStream resource group and give it a name. And then I'm going to configure my database, right? And there's different types of options. So what's the intent of this database? Well, I'm going to be using this one actually for transaction processing and mixed workloads, but you could also deploy a database that's tuned for data warehousing. You decide. It's the same Oracle database. It's exactly the same. It's just tuned a little bit differently. If you're using it for data warehousing, well, it's going to, when you create a table by default, it'll be using columnar stores for fast scans. If you're doing for transaction processing, when you create a table by default, it'll be row-based. You can always mix and match, it's fine. But by default, for example, that's one of the differences between two. But same great Oracle database, regardless. Then you specify certain things like, how much compute do I want? How much storage? And at the end of the day, you can start small, and you can have it go as large as you want. How do you like that? so as large as you want. So here, there's a concept called auto-scale, right? So in auto-scale, let's say I start my compute at 10 eCPUs. My workloads increase. Well, it'll automatically increase your compute based on your workload requirements. And then as soon as the workload dies down, the compute will automatically die down as well. Great, so here we go. I'm going to specify a couple other things like my backup retention, my user ID, my password for the admin user. I'm going to go into networking, add this to my virtual network. Awesome. I deploy, and a few minutes later, I have my Autonomous Database. Okay, so now that I have my Autonomous Database deployed, the great news I have is all these great Azure tools at my disposal, but I can also go into use some special sauce from Oracle. If I want to manage my database, increase the CPU utilization, change the storage, that's fine, right? Go into the resource allocation. The database is going to keep running. It never goes down. It keeps going. We also have different types of tooling, right? So things like, I don't know how many of you use things like Apex for low-code development tool. It's a low-code development tool. Or in-database machine learning or graph analytics, or all these different types of capabilities are just built in. So you can use these if you like. You have the full access to the Oracle capabilities. And you also have you have access to all of the database management features, right? Things like, and we just spun up this database. It's kind of a boring screen, right? But this is the database performance hub, right? Built in, and you have access to that as well, right? So if you're used to using Performance Hub, it's the same thing. Awesome. Okay, so I've spun up my database. How many of you knew that Oracle database can also be used as a JSON database? Anybody? Yeah, it's kind of cool. So you can build apps really flexibly using, for example, a MongoDB API on top of the Oracle database. And so you get the flexibility of your app dev, but then afterwards, you also have flexibility to project that JSON data in different ways for analytics, right? So store your data once, but use it in multiple ways. It's easy, it's fast to develop and to innovate, and so that's kind of what our mission is here. So let's go to segment number 2. We'll go through that demo. And I gotta say, my guess is I'm probably one of the first people to start an Oracle database demonstration in MongoDB Compass, right? Kind of strange. So I actually connected Compass to Autonomous. And I'm looking at the JSON collections that have been defined here, and I'm using the database as if it were a Mongo store. It's API compatible, right? So here you can see I have things like I have a movie collection, a customer profiles collection, all these different things, and I'm working with the data as if it were, I have no idea that it's Oracle under the covers, right? I can do simple queries to complex queries. I want to look up the movie Big. Here's information about the movie Big. I want to do a more complicated query, a more sophisticated query, just using the MongoDB syntax. Say, hey, I want to look at Academy Award winners after 1990. Terrific. Here they are. Guess we have Gladiator. It's won a lot of best pictures and best actors. You have Steven Spielberg's probably responsible for half of these movies, right? So you're working with this data really, really easily. Let's create a new collection, because we talked about we want to do, MovieStream wants to create watch parties. So I'm going to create a new collection called watch parties, and I'm going to load all that data into the collection from a local file that I have here. But just imagine creating watch parties. It's like, hey, I'm going to watch a movie with Cambyse. We're going to watch Big together. It's going to be really fun. We're going to have a little watch party. So here we have a watch party where they're watching Guardians of the Galaxy. This is Annabelle's watch party. She's going to watch with a bunch of her friends, and you can see the list of all these people. Okay, well, this is great. So now I'm going to jump into a VS Code. We have some great plugins to VS Code for SQL Developer to be able to run queries, write code, debug your code, all from within VS Code. Well, I just created this watch party collection, and I can see it here as the native JSON documents, right, that have been defined. Pretty cool, tough to query. So what we're going to do now is use Oracle SQL on top of that and basically say, well, let's look at this from a relational perspective. And that way I can combine it with other data, like lookup tables, transaction tables, et cetera. Right? I'm also going to have different projections of this same JSON collection. One is for reporting, right? Here's the high level. Here's all of my different watch parties that took place, when they took place, et cetera. But I have another view. And this other view is going to be used for a different purpose. In this case, this view is going to be used for graph analytics, right? Because graph analytics is a little bit different. I want connections. I'm watching with Cambyse. Cambyse is watching with Ram over there, right? So you have all of these connections. That's a graph, right? And so we can use graph analytics over this same data. So we're just projecting. You're storing the data once, but projecting it in different ways for different types of analytics. Okay? Cool. So I've created my database. I've loaded up some data. Now I want to just start asking some questions. And I'm going to ask questions using natural language, right? And what we're doing is what we're going to show is using kind of what's going on under the covers, what kind of extensions we've made to SQL to make it easy to query that data. And then we'll also show you an app that you could deploy real easily to your, across your organization to ask questions. The key message here, what we tried to do is make it so that any application can easily be extended with natural language. If your language can speak SQL, then your application can now be a natural language query application with very, very minimal changes. There's no custom APIs required. You just ask your question. So let's take a look at how that works. So it starts with, and I'm back in VS Code here, and it starts with creating what we call an AI profile. An AI profile is quite simply what AI model do you want to connect to? In this case, I'm going to be using Azure's OpenAI, like GPT-4. And what tables do you want to participate in natural language processing? So these are going to be sources for when you ask questions. These are tables that are going to be used. Awesome. So I create this, and you can plug into different models. GPT-4 is pretty great. So that's what we're going to use. And now here's the magic. OK, now just start asking some questions. Select AI. How many movies do we have? The only thing that's probably familiar, how many of you write SQL? Yeah, the only thing that's probably familiar to you is the word select, right? Everything else completely different. So you use the word select and then the keyword AI, and then you just ask your question, right? And so then under the covers, this is going to talk to a model, in this case GPT-4, take that language, turn it into SQL, and then run that query, right? So any tool, like right now, we've done nothing. Like this isn't using, gosh, Copilot's amazing, right? This isn't using Copilot. This is literally built into the SQL language, right? We've extended the SQL language so your app can do the same thing that we're doing here in VS Code with like very minimal changes, because it's just plugging into, it's the same processing, right? And so you get your results. How many movies do we have? Well, we have 3,800. Select AI, what are the most popular watch party movies? Those are JSON documents, right? that we're querying, right? So that's the data that came in through the MongoDB API, and we're saying, these are the most popular watch parties. AI on top of JSON data. Cool. Well, what's going on under the covers? OK, so there's different keywords like explain SQL, show SQL, that let you see what's happening in terms of the processing, right? In this case, it's that question that we asked was joining multiple tables, a demographics table, a streams table, joining on the customer ID. And then it gives you an explanation of what that processing actually is. All right, well, that's the underpinnings. So now any app can take advantage of that. Right? One of the apps that's going to take advantage of that is a really simple app that we created literally in a couple days using Apex. Apex is a low-code development tool. This is a great thing to run on your phone, right? You're on the move, you want to ask a question, you ask a question on your phone, you can say, hey, what are the top 10 streamed movies? And it goes back, asks the question. Like, it's just a front end to what we just looked at. Really, really easy. The nice thing is that Apex has all sorts of capabilities that now that you've done that, you may want to see things like, hey, download that to a spreadsheet. Share that with others. See it as a chart, right? The world is your oyster. You can build any type of apps that you want on top of this right now. This is all built-in capabilities that are part of Apex. And you get to use your language, right? I'm not sure what that's being asked, what was asked there, because that's in Italian, and I don't speak Italian, but Dom does. So maybe Dom can help us out. Or in Chinese, right? Ask the question in Chinese. So you use your language to ask questions. I'm pretty good with the English side. I'm kind of OK with the English side. Not perfect, but lost on the Italian and the Chinese. All right. How many of you knew? How many of you know that Autonomous Database can be used as a graph database? Well, what we're going to do now, you have your data in relational tables. We have those JSON documents. We're going to create a property graph on top of your existing data without having to move the data or transform the data. It's there. We're just going to create a new graph over your data, and we're going to discover communities, and we're going to do all sorts of graph analytics, right? Beauty here is that you can immediately start gaining insights from your data, connections, like things that, you know, I'm very much, I started in the multidimensional world. I used to always think about things in cubes. And now I work more on relational world. But now I'm thinking of things in terms of connections, which is like really, really cool. And that's what we're gonna do, is we're gonna discover communities and patterns over the existing data. Okay, let's do it. So we're gonna be planning a watch party event, right? So as part of that watch party event, what we need to do is basically find customers who are similar, right, who live near one another, and rats, sorry guys. Let me just start that again. I always do live demos as opposed to these, and I sometimes struggle with it. So we're gonna plan a rewind. We're going to plan our watch party event. And so here we go. Now, remember, we went back, we looked at this is the original JSON data that we looked at, and that data we projected as a graph with the who did I watch, who's the watcher, whom we watch with. That's going to form one of some of the edges of that graph. So Autonomous has something called Graph Studio, which lets you then create graphs over your existing data. So you can see here we have vertex tables. Those are the points that are being connected. Customer, what has a customer watched? And then or what are the movies? And then they're connected by, well, who did I watch with? And they're also connected by streams. What did people stream? So you have this graph and connectivity that is built out. Cool. Now you can use a graph syntax to start querying that data. So this is it's called PGQL. It's a specialized graph syntax. What's nice about this is we're saying, hey, I want to see movies. So I'm starting with Nikki, and I watched with Kambiz, who watched with Ram. I'm doing a multi-hop query to see some connections between people. And think about this. We're moving towards the creation of communities, right? And if you look at this, you can see, okay, here's a Nikki, and she's been involved with a few watch parties. But if you look at the top, right, we have, I think her name is Emily. Emily is someone who may be an influencer, right? You can see she's got a lot of connections to other people. So if I'm going to be reaching out to people, I'm going to want to reach out to people who are highly connected, right? I want to find like who are leaders of this community. These graphs get big, right? So imagine this little graph kind of gets hard to see. Imagine as you get hundreds of thousands of people and the connectivity between people and movies and all that, hard, right? And this is when you need to start using things like algorithms, right? So what we want to do is we're going to use a community detection algorithm in our graph to be able to see, have the graph engine do the work, right? So there's like 60 some odd algorithms. And we're right here using a community detection algorithm. And those communities are built based on relationships and based on connectivity and the strength of those connections. And so when you run this, it's going to create all these different communities of people who are similar based on extended friendships and based on what they've watched, right? So we've run that community detection algorithm, and you can see that this is Pi community number 99248, whatever, has 687 people in that community. Okay, so now we've got a bunch of people who are friends from an extended friends, and they watch similar things. We're going to plan an event, right? We're going to bring everybody together who are similar like that. Great. So we're going to look at the movie that we should play at that event. We're going to look at the people who are in that community. These are their email addresses. And I'm going to save these people and these communities into it as a table into the database, because that's gold. Like that information about communities, their behavior, that's gold for marketing, right? So I'm going to hand that off to marketing so they can use that information. And now I'm going to use it also to say, well, I'm going to have an event at Bryant Square Park in Minneapolis, and I'm going to find people who live within 5 miles. So now I'm doing a spatial query on top of JSON data, on top of relational data, like on top of this graph, right? This is where analytics, it's nice when it's all in one place, because you can do all these different types of analytics on the same data, right? And so now I'm only going to invite people who are within 5 miles of the venue, right? Awesome. I'm going to take that information. I'm going to start inviting people off. I have everything I need, right, to run this event. OK, well, how would I create these emails? Well, I'm going to use AI to do that, right? And that brings us to our next segment. I want to deliver AI APIs and new applications, right? And new services that are going to delight my customers. And so we're going to design these APIs, and then we're going to publish them to Azure's API management service so they can be consumed across all these different apps, right? And this is actually really, really straightforward. So the key is that it's really simple to design these APIs on top of data that's in the database and share those across the Azure ecosystem. Cool. So this is our last segment. We've done a lot. All right. So I'm going to start now in VS Code. And what I'm going to do is say, well, I want that promotional email sent out. And I'm going to actually be able to do that with a simple query. Because the goal here is to say, look, I want to create a promotional email with a catchy subject line and convincing text. And these are the rules. I want to recommend 3 movies based on those that we want to promote. We're promoting movies with Amblin Entertainment. I want to base what I'm going to recommend to Kambiz based on what he's seen before, right? To make those similar. OK, and then I'm going to make this into a really fun email to him. Well, the challenge is that's great. Like OpenAI is amazing at doing being really creative, but it needs your data, right? It needs to know, well, what did Kambiz watch? What do we want to promote? And that's all part of this query, right? So literally in one select statement and a function that we have that communicates, that works directly with OpenAI, right? We're able to do this in minutes, right? So I'm going to say, well, the first thing I'm going to do is at the top, this is my promoted movie list. OK, I'm going to be promoting movies from Amblin Entertainment. The next part is, what movies has Kambiz watched? OK, here's the movies that Kambiz has watched. Collect that information. All right, well, let's get some demographic information about Kambiz. Stunningly good-looking man, wears glasses, all sorts of stuff. And then I'm going to package that as a JSON document, right? I package all of that information as a JSON document, and you see the little word doc at the end? That's the data that OpenAI knows nothing about. And we're augmenting the prompt to OpenAI. So with a single select, I'm now able to see, I'm now able to create that promotional email. Hey, Jeannie, we hope this finds you well. You love Terms of Endearment, Up, and Paranormal. Based on that, you might think you're going to love Back to the Future and Why, and you're also going to love E.T. and The Goonies. Simple, right? Simple to integrate your data with the LLM to have these customized promotions. Great. Well, you know what? This is a query. I also have different promotions out there, like different procedures and functions that I also want to publish. I'm going to want to publish this query. I'm going to want to publish this thing called Create a Bedtime Story. So within ADB, we have a REST designer, right, where you can create REST endpoints, create APIs on top of queries, on top of functions, right? So let's do that. We're going to go into the designer, and we have a module called API. And under API, we have all these different templates. One of them is that promotion. I want to do that promotion to the customer. And if I look at that promotion, this should look pretty similar to what we just looked at. It's the same query, right? This is the query that we just looked at, but we parameterized it. So now we have a parameterized query. We exposed it through REST, and now you can start using that. Terrific. I also have another API. So this is the actual query we just looked at. I have another API for creating a bedtime story, and that's looking at a stored procedure that's in the database, right? So we have a couple different APIs. Well, I want to make these available through the Azure API management service with all the other APIs that have been defined, right? So they both subscribe to the Open API standard, right? So what we're going to do is quite simply, export these APIs using the Open API standard, go into the Azure API management service and import them. And so now all my database APIs are being managed on the Azure side. And here's that create a promotion. And let's test it out. I want to test out my API to what's her name, Jeannie? I think it's Jeannie. And there you have it. Lights, camera, action, right? Here's using that live data. We also have another API called Create a Bedtime Story. And this is where, hey, MovieStream's creating new services to delight its customers. And in this one, for this customer, we're going to specify things like, hey, what movies did they watch in the past? From my customer profile, who should this new bedtime story be targeted to? Should it be starring? Well, in this case, it's going to be starring Sari and Mom. And it goes off, runs, and there's your result. Sari's Magical Adventure. Well, let's create an app. So now we have an app, and we're going to connect and create a new bedtime story. And I got to tell you something. This is like the favorite thing I've ever done at Oracle, because I have such fond memories of snuggling with my kids and watching movies with them. But in order to do this, we need to know there's private data. There's data that's private to MovieStream that the model needs to take advantage of, and that's what we're doing right here. So we're going to create our new bedtime story, and we're going to base this on, I really liked, these are movies that we watched together, so based on Frozen and The Lion King, and it's going to star Dad and Charlie. Let's write my story. It's the adventures of Charlie and Dad, right? And here's this great story. And your kids are going to love it. It's like movies that they just watched, starring them. Really, really fun. So that, my friends, is how Oracle MovieStream is delighting its customers, and how you can too. So, it's kind of amazing, like the power of the Azure services and all these great capabilities, and combining it with the database, the Oracle database, to develop new solutions quickly, and taking advantage of the best of both is pretty dramatic and pretty kind of mind-blowingly awesome, in my opinion. So, we have, I know we're kind of at the very end here. So in the hub, come visit us, ask questions. Do we have time for questions? Or you guys want to, anything that you would like to add?
Yeah, and the best part is, while the database is being automatically, magically managed.
That's
While it's being automatically
That's right.
managed.
There's nowhere in here we're talking about provisioning. There's nowhere in here we're talking about the infrastructure, resources, patching, anything about you need to really worry about database or data estate management in this case.
Right.
Yep.
All right.
Okay, thanks for being here. I appreciate it.